Welcome, I'm Clemens Porteler from Interactive Instruments in Germany. In Testbed 13, we investigated workflows for using data that was captured according to the framework of the US National System for Geospatial Intelligence, NSG. Our focus were specialized applications that do not support NSG data directly. The background for our investigations is the following story. A dataset with urban data has been captured for use in the NSG. An analyst discovers the dataset and wants to use the data, together with other data, in simulations and for visualizations as 3D city models. She wants to use the data in applications she's working on a daily basis. In Testbed 13, we looked into workflows that the analyst and a team of data experts can go through in order to bring the data together in these applications. Let us now briefly introduce the types of applications that we have looked at in this testbed. The first type is a computer simulation that provides a synthetic environment with a high level of realism. A wide range of data, including geospatial data, is used in such environments. The CDB standard of OGC defines a standardized model, structure, and data store for a single virtual representation of the Earth. To enable the use of NSG data in this environment, we had to understand how data that follows the conventions of the NSG can be converted for use in a CDB data store. The second type of applications is related to the visualization and analysis of 3D data in urban settings. Such applications typically support data that uses the format of the OGC standard CityGML. CityGML is an open data model in XML-based format for the storage and exchange of virtual 3D city models. The standard specifies the basic entities and their attributes and relationships. The data model can be extended in so-called application domain extensions, ADEs. Such additions comprise the introduction of new properties to existing CityGML entities or the definition of new ones. Before we get into more detail about the workflows, let us briefly explain some basic concepts. First of all, let us establish what an application schema is. An application schema specifies the content and structure of geospatial data that is required by applications. The modeling of an application schema follows standardized rules. The first task is to group the relevant things from the real world into types with similar characteristics. The second to specify the relevant characteristics. An application schema is a conceptual schema. It represents the domain knowledge and avoids the computing concepts from specific implementation environments like XML documents or relational databases. The NSG Application Schema, or NAS, is the NSG-wide model for geospatial data. It supports rich content like values from external vocabularies maintained as part of the NSG, for example, the roof type of buildings, reasons for missing values or separate information entities that are referenced from geospatial objects. This information is important for users like our analysts to understand both the thing in the real world and how the information about it has been captured. A schema on the conceptual level greatly helps to interpret data and transform it consistently between different representations of the same data. For example, between a database that is used to store and maintain the data and an XML file used for data exchange between systems. Another important benefit of an application schema is that its formal nature supports model-driven software development. This allows for a consistent and automated derivation of outputs that are required for the implementation in various environments. Examples are XML or JSON schemas for data exchange, database schemas to set up storage facilities, and many more. Model-driven software development requires an initial investment to establish the automated workflows, but once established, new versions of the application schema can be processed faster with less effort and fewer errors due to the automation. The open source software ShapeChange is a tool for processing application schemas for geospatial data, for deriving outputs for implementations and documentation. Some application schemas support a wide range of applications. The NSG Application Schema is an example of such a schema. Implementing such a schema in its entirety can be expensive and overwhelming. A common pattern, therefore, is to create a profile of the application schema. Either standardized profiles that are used on a frequent basis or mission-specific profiles for a specific situation. Such a profile only contains information that is relevant to the intended use and is therefore better suited for the implementation. In Testbed 13, an urban military profile of the NAS was defined and used. Application schema profiles can be defined and maintained using the Shape Change Profile Management tool. In Testbed 13, we developed and implemented repeatable workflows to generate outputs for profiles of the NSG application schema for our target environments, simulation using the OGC CDB standard, and visualization of 3D city models using the OGC CityGML standard. To do so, the CDB and CityGML standards were analyzed to identify a suitable conversion. The analysis discovered a number of challenges, especially for the mapping to CDB. These challenges were addressed and will provide input to ongoing standardization activities. For example, CDB currently uses shapefiles to encode feature data. As such, CDB geospatial data does not support the richness of the NSG application schema. This challenge was addressed by introducing a transformation workflow that transforms the application schema to a simplified schema that is compatible with shapefiles. That is, the schema has been specified as an XML schema according to the level 0 profile of the OGC GML simple feature standard. However, representing the rich NSG data in such a simplified data structure will always involve trade-offs. The transformed schema could then be converted to CDB feature and attribute dictionaries, which are currently expected by CDB applications to declare the geospatial objects and their attributes. At the moment, the CDB standard is limited to a fixed set of geospatial object types. To support the NSG and application schema profiles properly, it would be useful if the CDB standard would allow the use of all geospatial objects from the source dataset. To support CityGML application schema, an application domain extension, another type of XML schema, had to be derived. In this case, the NSG application schema profile had to be transformed first to link the profile to the geospatial object types defined in the CityGML standard. To summarize, new workflows were developed to derive a GML simple feature level 0 schema, CDB feature and attribute dictionaries, and a CityGML application domain extension from an NSG application schema profile. The workflows are repeatable and can be applied to other profiles too. These new capabilities have been added to the Shape Change tool and are available to the geospatial community. We identified a number of recommendations for CDB and CityGML, which will be fed into ongoing and future OGC standardization activities. This concludes our presentation. Thank you very much.